All right, here we go. I'm finally ready. Sorry about that. All right, here we go. So watch how easy this is going to feel. Super, super easy. So easy that you're probably going to make the silly mistakes again. You're going to add wrong. You're going to multiply wrong. So let's watch our signs. Let's not make any silly mistakes. All right, so technically, we are all the way back in section 4. I am calling this part 3, operations with imaginary numbers. All right? Imaginary numbers. We know that they got introduced to us when you took the square root of a negative number. If you take the square root of a negative number, that cannot be a real number answer. So we got introduced to the imaginary number I. Mathematicians back in the day, they needed a way to work around the square root of a negative number and still get some solution. It's not a real solution, but it's a solution, okay? So the imaginary number I was brought in. They said, let I be the number whose square is equal to -1. That's how it was introduced to us. They said, let I be this number that when you square it, he equals something negative, which shouldn't happen. When you square something, it should end up positive, right? So they said, let it be -1. And the reason they chose -1 is because it's so compatible. -1 divides evenly into every number in this world, all right? And then if that's true, we were able to do ourselves, if we took the square root of each side, then we found out that just I was equal to the square root of -1. So those are the two pieces of information you have been told about I. But guys, you have to recognize something. I squared has a very, very real number value. He equals -1. That's a real number. So there is absolutely no reason to ever leave I squared in your answer. I squared can always be taken out and replaced with -1. He has a real number value. But we always leave I in our answer because we don't want the square root of a negative number to be in our answer. So instead of having the square root of a negative number in our answer, we put I. So I will stay, I squared will not, okay? All right, so when you are working with imaginary numbers, they technically fall into 2 categories. We have pure imaginary numbers, and those are going to be numbers that can be written in the form BI, where basically there's no real number counterpart. It's completely imaginary. So when you took the square root of -64, you got 8i before. That's pure imaginary. He is a completely imaginary number. If you are working with just I himself is a pure imaginary number, even if it was negative. -3i is a pure imaginary number. They have no real number separate part. But then you could have a complex number, like we saw to the answer of our equation. A complex number is a number that can be written in the form a plus bi, where now he has a separate real number part and a separate imaginary part. So A represents the real number part, and BI represents the imaginary number part. So when we solved that quadratic equation today, and we got 9 plus 4i as our answer, and 9 minus 4i as our other answer, those are complex, because they have a real number, they have 9. But then they have a separate imaginary part, 4i and -4i. So we're going to be asked to perform operations with complex numbers. Add complex numbers, subtract complex numbers, multiply them, divide them. It's basically going to feel like you're combining like terms and you're distributing. That's all it's going to feel like, all right? So when you work with complex numbers, there's a specific way they want you to write your answers. They always want you to write your answer in standard form of a complex number. And standard form of a complex number is that form right there. It's a plus bi. So all that means is when you go to write your answer, make sure you put the real number first and the imaginary number second. That's all that means. Don't put the imaginary number first. It always goes real number, then the imaginary number. All right, let's try it. Let's watch how easy this is going to be. All right? So today, I'm just going to have you add complex numbers, subtract them, and multiply them. I'm going to save the division for its own day, because unfortunately, the division's it's not as nice as the adding and subtracting and multiplying. So we'll save that for its own day. Let's do the real easy stuff first. All right, so the directions say, simplify the following expressions. So simplify always means get rid of any parentheses and combine any like terms. Get it as simplified as you can. And then notice, the directions are always going to say this. Write your answer in A plus BI form, or they'll say write it in standard form of a complex number, which is A plus BI form. And again, all that means is we're always going to write the real number first and the imaginary number second. All right, so look at example 1. Basically, in example number 1, they are telling you to take this complex number, negative 5 minus 7i, and they want you to add it with this complex number. Well, unfortunately, you're really never going to be able to add anything until you get rid of the parentheses. And since we can't do inside of any of the parentheses first, right, I can't take a negative 5 and minus 7i, I can't take a 2 and add a 9i, they're not like terms. So since I can't do anything inside the parentheses, we always look to the outside to get rid of them. So guys, what number would you have to imagine is in front of this parenthesis? A 1. So distribute your 1, but if you distribute a 1, does anything change? No, it'll still be negative 5 minus 7i. And then to get rid of these parentheses, look to the number attached to the front. What number do you have to assume is attached here? Plus 1 again. If you distribute it, does anything change? No, that'll be positive 2 and positive 9i. So at the end of the day, if you're going to add complex numbers, you basically ignore the parentheses and combine like terms. So we're going to add our real numbers together, and then we're going to add our imaginary numbers together. And it should literally feel like we're combining like terms. So guys, if you had negative 5, a real number, and you added it with 2, what real number do you end up with? Negative 3. And then if you had negative 7i's, and you added them with 9i's, how many i's do you really have? 2. Negative 7 and positive 9 is positive 2i's. And you're done. And you are written in A plus BI form. The real number was first, and your BI was second.
You could just do it without like having to like.
Why am I listening to music? Whose music is on?
That was my mouth.
That was your mouth?
Right.
Oh, it sounded like legit music. Sorry. All right, and that's it. That's literally, you're going to sit here and say, no, that's too hard. It's too easy. Yeah, let it be, let this be easy. Go ahead.
Wait, so you're not like, you know how like you have to get on the other side, like.
There's no equal sign. These are expressions. If there was an equal sign, that would be different. That would be an equation. We are just simplifying algebraic expressions.
So if there was an
This is
sign,
bad. It's so easy. Say it again.
If there was an equal sign, it would be 16.
Well, it depends on where the equal sign was and who we moved where. Okay? But again, to solve this for I, that's where I is not like a variable. We know who I is. He's the square root of negative 1. I just don't want to put that in his place. Where x represents some unknown number. We know who I is. So you're not really solving for I because we know who he is. All right, look at this one. Now they're asking you to take this complex number and do what with the next complex number? Subtract. Now they want you to subtract them, right? So now we're subtracting. However, subtracting will be a little bit different than adding. You still have to get rid of the parentheses. So who do we assume is in front of this one? 1, right? Doesn't change a thing. 4 minus 8i. But who do you have to assume is in front of this one? A negative 1. And that will affect it because you have to make sure that you subtract all of this number. So when you distribute a negative 1, what's negative 1 times 3? That's a negative 3. And what's a negative 1 times a negative 6i? A positive 6i. So it does change the signs in that second parenthesis. So the first parenthesis stays the same, but distributing that negative changes those signs. And now you combine like terms, but you want to be in A plus BI form. So real numbers first. What's 4? Take away 3.
1.
So now what's 4 take away 3? 1. And now you're going to have negative 8i's and plus 6i's, leaving you with how many i's? Negative 2i's, and you are done. You are in A plus BI form. You have your real number. You have your imaginary number. All right, look at example 3. They're not necessarily asking you to add 2 complex numbers or subtract them. You're basically simplifying a complex expression. Your job is to get rid of these parentheses and combine any like terms and leave your answer in A plus BI form. So PEMDAS would always tell you to start inside, but we can't do that. So we look to the outside and who's attached? Negative 1. So drop 11 down, make him come down, wait his turn. We're not ready for him. Let's distribute the negative 1. So what's negative 1 times negative 4? Positive 4. What's negative 1 times positive 2i? Negative 2i. The parenthesis stops, and then we just drop down our negative 1i. And now everything's ready. We just combine our like terms. Real numbers first. What's 11 plus 4? 15. And then we do our imaginary numbers second. If you had negative 2 i's and you took away one more I, how many i's you playing with? Negative 3i, and you're done. That simple. So this should literally feel like we are back in section 1, just nice, easy algebra. Is everybody okay? So that's how you're going to be asked to add and subtract them. Now we're going to get into the multiplying of complex numbers. So first, let's start with just straight up multiplication. There's no addition, there's no subtraction. We are taking a pure imaginary number 3i, and we are multiplying it with a pure imaginary number 5i. Guys, does the order in which we multiply ever matter? Is 3 times 5 order different than 5 times 3? No. So when you think about how you're actually multiplying 3i with 5i, you're basically multiplying your numbers with numbers and your i's with i's. So I'm just going to rewrite it in a better order. You're basically doing 3 times 5 times I times I. That's what's happening here. You can really multiply that in any order you want. So now what's 3 times 5 going to be? 15, and then I times I is I squared. Are you going to leave that as your final answer? No, because remember, I squared has an extremely real number value. Who did we say I squared is equal to? Negative 1. So really, 15 times I squared is 15 times negative 1. And now what's 15 times negative 1? Negative 15. And you actually end up with a real number answer.
Wait, I'm confused. Wouldn't, since it's like a square, then we should do negative 1 times negative 1?
No, because I is the square root of negative 1 times the square root of negative 1. That's who I is. I is the square root of negative 1, right? All right, so now let's look at the next one. So now it's not just two imaginary or pure imaginaries. We have a pure and we have a complex. If we want to multiply this out. Again, PEMDAS always says to start here, but you can't do it. So we look to the outside, and now you're going to distribute in your negative 2i. So what's negative 2i times 6? 12i. Just again, treat it like it's an x. Negative 12i. Now we go to the next one. Now we have to do negative 2i times negative 7i. Multiply your numbers and then multiply your i's. So you're going to get what number? 14i squared. Are you going to leave that as your final answer? No. Guys, at the end of the day, 14i squared is positive 14 times what number really? Negative 1. And what's positive 14 times negative 1? Negative 14. So really, this expression is really negative 12i, who we got first, and then really all of that became negative 14, so minus 14. That is the expression you really get when you multiply that all out. Are you going to put that as your final answer?
No.
What's wrong with it? The order, right? We need the real number first, and the amount. So all we have to do is flip-flop, but don't lose your signs. This was a negative 14, so he should go first. And this was a negative 12i. He should go second. Just don't lose your signs when you have to switch their order. Go ahead, Brendan.
So you can add. You can multiply an imaginary number
With a real number. Because the imaginary part just kind of carries through like I. It just carries through like a variable.
You can't add.
You can't add them though. Yes. Good point. All right, bring back some memories here. So guys, look at number 6. This is where you want to be careful. This is where you make a harder process, or an easy process harder, I should say. If it's going to be adding or subtracting, guys, they're going to put a symbol in the middle of the parentheses. This clearly says to take this and add it with that. This says to take this and subtract that. Some people just see the parentheses and they immediately start like foiling and distributing. Here, though, do you see a plus in between? No. Do you see a minus in between? No. This, the parentheses are attached. This is a multiplication problem. And how are we going to multiply this complex number with this one over all of this addition and subtraction?
Would you put the 1?
Not the other F word.
Factory.
No, the other F word.
Fraction.
No. A lot of F words in math. Foil. It's a foil, right? Your first, your outside, your inside, and your last. I don't really like to call it foil. I always think of it as you're just double distributing. If this was just 2i, we would distribute 2i and be done. But it's not. So you're going to take each one of these terms and distribute them one at a time. So I always start with the first number in the first parenthesis and start distributing him to the next parenthesis. So what's 4 times 5? 20. What's 4 times positive I? 4i, positive 4i, don't lose your sign. Now have you taken 4 and multiplied him with everything over here? Then you're done with him. So now you go to the next term of the first parenthesis, and that's negative 2i. Now we distribute him to the second parenthesis. So what's negative 2i times 5? Negative 10i, beautiful. And then last, be careful, negative 2i times positive 1i. Negative 2i squared. Way to redeem yourself. All right.
This is going to be our.
This is literally going to be your quiz. I'm telling you, you're going to get another 100, okay? We haven't done the division yet, but we'll be fine. All right, here we go. So now the first thing I do, because this one has a couple cleanup parts, the first thing I look at is the I squared. Let me get rid of him. Let me see what number I really have, and then I'll combine my like terms. So guys, at the end, you usually end up with some I squared term. So at the end of the day, this is really a negative 2 times what number? Whose I squared? Negative 1. And who's negative 2 times negative 1 going to be? Positive 2. So really, this is a plus 2. So that's really the number at the end of this expression. Now, I'll go and combine my like terms. So let's do our real numbers first. What's 20 plus 2? 22. And then your imaginary numbers, positive 4i's take away 10i's is? Negative 6i's. And you're done. But it's just foiling, and I know you guys know how to foil. All right, on the back, you guys do number 7. Foil that out, multiply it all out, get rid of your I squared, combine your like terms. I'm telling you, it's only going to be something silly that you do wrong. So make sure you're multiplying right, make sure you're watching your signs, make sure you're adding things correctly. No silly mistakes. This is too easy to get the wrong answer. Try and give you guys a head start. Watch your signs. And again, don't forget, when you distribute, that's a multiply step. You should be multiplying this together. And then when you combine, that's an adding step.
Is this right? Yes.
I think so. Looks good to me. Oh, wait, hold on.
Oh, no, I got something.
With that ball, it's a 9.
Negative 3 times 2 is negative 6. Then you have negative 3 times negative 3.
I don't do that.
Okay.
It's like,
Boom.
I always do that.
But you're going to have a positive 7i times a negative 3i. So that'll be a what kind of 21?
Oh, negative.
Yep, and that'll affect what you get. All right, let me get this part. All right, double check that you have the same 4 terms from your distribution. And then it's all about, to me, I go right for that I squared. Let me get him out of there. I know he's not going to stay. That's a negative 21 times a negative 1. Really, what number is that? That's a positive 21. So make sure you fix that. Now I can combine my like terms. So I have negative 6 and I have 21. So if I had 21 and I took away 6, now I have 15. And then 9i's plus 14i's gets me a total of 23i's. So you should end up with that. All right. And then if you remember, when we were foiling, these ones always pop up too. Go ahead, Chris. Because negative 3 times positive 2 is negative 6. Negative 3 times negative 3i is 9i. 7i times 2 is 14i. And then 7i times negative 3i is negative 21i squared. which is negative 21 times negative 1, so really that's a plus 21. So negative 6 and positive 21 get me 15, right?
So wait, so when you have this squared and then you fix it, there's no number I anymore?
Well, when you multiply an I with an I, it's going to create an I squared, and you're going to replace it with negative 1. And it usually then makes this the opposite of whatever number was in front. Does that make sense? Okay. All right, here we go. So these ones kind of popped up too. When you guys get here, there is a mistake that math is hoping you are going to make, but we're not going to fall for it. Always remember what it means to square something. When you square something, what is it telling you to do?
Double it.
Not double it.
Well,
Do it again.
the same-
Times it by itself how many times? Twice. So we're going to take this and we're going to times it by itself twice. So we're going to take negative 2 plus 6i and we're going to times it by itself. That is literally the definition of squaring something. When math gives you a problem like this, they are hoping and praying that somebody does this. They hope that you see this and you're like, oh, you want me to square this? Okay. Negative 2 squared is 4. 6i squared is 36i squared. They are hoping that you distribute that exponent over that addition and subtraction. But guys, in math, you are never allowed to take an exponent and distribute it over addition and subtraction. And this is why. Really, really easy. Guys, what if I gave you this problem? What's 3 plus 4? PEMDAS says to do inside. 7. This is 7 squared. Who's 7 squared? 49. The answer to this problem is 49. But if you said, oh, I'll just square 3. Who's 3 squared? 9 plus, I'll just square 4. Who's 4 squared? Is 9 plus 16 49? No. So you're never allowed to do that. So always stick with about your squaring rules. It means to multiply it by itself twice. And then once you do it, what kind of problem does it become? It's a FOIL in disguise. That's all they are. And now we're just going to distribute this right out. So what's negative 2 times negative 2?
Negative 4.
Oh, positive 4. What's negative 2 times positive 6i? Negative 12i. And then we're going to distribute our positive 6i. What's positive 6i times negative 2? Negative 12i. Now, normally with these squaring ones, you end up with the same middle term twice. They don't cancel because they're both negative, but you get the same term twice. And then last, what's a positive 6i times a positive 6i?
36.
I squared. And then I go right for that I squared. Let me fix him. That's really a positive 36 times what number? Negative 1, which really makes that a negative 36. So now when you go to combine, we have 4, but we took away 36. So what number do you really have? Negative 32. And then in the middle, we have negative 12i's and negative 12 more. What number is that? Negative 24i's.
I got a negative 40.
How'd you get negative 40? Is this but negative 2 times negative 2 is positive 4.
Oh,
And then that becomes a negative 36. All right. I would like you guys to do the last one. You guys do the last problem. Square that. Write it twice and FOIL it out. Number 9. I think it's 5 minus 8i squared.
Yeah.
I'm trying not to move my board. Well, you can. To make sure you're multiplying and adding correctly. But this is what your homework's going to be on. Nice, quick adding, multiplying, subtracting, like terms. Right? Write it twice and just multiply that out.
Come out tonight and see our Mr. and Mrs. Mariner.
Oh, crap, I didn't know it was this late.
Entrances, questions, and answers.
It's just like a fun
Friday,
contest.
6 p.m. in the auditorium.
$3
$3 in advance, $5 at the door. Come one, come all, you'll have a ball.
Is it 2 big numbers?
It's negative 39 minus 80i. I didn't realize it was that late.
Negative.
Yeah, negative. That's going to be negative 64. Guys, there is homework on Delta Math. It's due tomorrow like normal.
Dennis Ronnie, please report to your bus. Dennis Ronnie, please report to your bus. Ryan Dickerson, please come into the office.
Yo. Yeah.
Bless you. You too. You too.
This is someone's.
Oh, thank you. See ya. You too.